So this is question 29, and we need to sketch and analyze the graph once we draw the sketch. So first thing I do whenever I'm provided with a log equation, and I'll be fully honest here, I feel more comfortable with the exponential version. It's just easier for me to fill out a table if I have the exponential version. So here is the alternate equivalent exponential form of that log equation. 5 to the y equals x. And so what I'm going to do is I'm going to figure out if y is -1, what is x? If y is 0, what is x? If it's 1, what is x? And if it is 2, what is x? And so if y is -1, 5 to the -1 power is 1/5. If it's 0, 5 to the 0 power is equal to 1. And then if it's 1, 5 to the first power is 5. And if it's 2, 5 squared is 25. So it's kind of funny. I'm filling out my table backwards, but that's going to allow me to draw, a pretty good sketch of what the log function looks like. So there's my x and y axes. Plotting the points, I just have to go 1, 2, 3, 4, 5 to the right. I'm not even going to bother to plot 25, 2. I just don't feel like making the x-axis go out that long. So I'm going to plot 5, 1 first. So that point is here. 1, 0 is here. And then 1/5 -1 might be about here. So knowing what we did in class, just going to connect these three to make that soft logarithmic curve. And understanding that this downward section of the curve right here is getting closer and closer to the y-axis, but it will never touch the y-axis. And so I think that might be, a pretty quick way of graphing the function. And I am going to leave you here to do the rest. So make sure that you talk about your domain and your range, your x-intercepts in this case, your asymptote and your end behavior. As well as an interval where it increases. So since you have this graph here, you should be able to answer all of those questions.